Hey guys, and welcome back to my CCNA 200-301 course. Patrice is here, and in this video we are going to configure an IP version for a standard access list. Are you ready? Let's get started. Alright guys, this is our today's scenario. We have three PCs. Two is in GNS3, I mean emulated PCs, 1.230 and 1.231, and 1.210 is my personal computer. We have two routers, router 1 and router 2. The subnet on the left side of router 1 is 192.168.1.0, and on the other side between router 1 and router 2 is 192.168.2.0. I configured SSH on this router so we can test our access list on the remote connectivity and remote SSH from these PCs to router 2. First, I'll show you all of these three PCs would be able to SSH to the device, and then I'll be applying the ACL and show you how ACL can restrict your traffic. Let's start from PC 1. To test the connectivity to port 22 or SSH, I run this command on this emulated device. Ping 192.168.2.2-3, which is telling the GNS3 to run a TCP ping. And then I'm using -P22, which means I'm gonna test this connectivity on port 22. So as you can see, I have some connectivity here. So the device is trying to connect, send data, and then the communication is getting terminated. So there is a communication between PC 1 and router 2. Same thing from PC 2, ping 192.168.2.2-3 and -P22. And as you can see, I have connectivity between PC 2 and router 2 as well. And finally, from my personal machine, I open a new session here and trying to SSH to 192.168.2.2. As you can see, PuTTY is prompting me for login to 192.168.2.2. So basically all of these three devices are able to SSH to router 2. Now what I want to do is restricting access from PC 1 and PC 2 to be able to SSH to router 2 or any other communications, because if you remember that we said for IP version for a standard access list or even IP version 6, you can restrict the traffic based on the source IP address only. So if we add this ACL to our traffic, it won't only restrict the SSH. It will deny everything, including SSH, but this is just a lab and we want to demonstrate the things. If you remember from the previous video, I said if you want to apply or implement ACLs, the first step is defining the ACL. So as the first step, we have to define our ACL. To define the ACL, we go to global configuration mode and we say access list. And here, as you can see, you can give it a number, or if you want to use named access lists, you have to say IP access list. And then here you can use a standard, and then you can use a name as well. We'll be talking about the IP access list in the upcoming video. For now, just assume that we want to add very simple a standard access list. So we say access list, give it a number from the range for standard access list. You remember that from 1 to 99 or from 1300 to 1999. So I would say 1. The next action you need to do is allowing or denying the traffic. With permit, you allow that specific traffic you want to say in the remaining of this line. And also you can deny the traffic. And if you remember that, I said the order is too important, so you need to be careful. Remark is for documenting your access list. So your first line of your access list, can be a description about what this access list is going to do. So I would say remark, this access list is going to allow PC 3 only, something like this. Okay, so you define a description for your access list. And in the next step, we have, again, these are our ACE, access list entries. So every time we mention access list and access list number. And then this time I want to say permit, and we have some options here. If you want to mention a specific IP address, you can use host and put a single IP address in front of it, or you can use the IP address and then determine the wildcard mask. So I would say 192.168.1.2.10, and as the wildcard I say 0.0.0.0, which means only 192.168.1.2.10. And in the second line, I would say access list 1 and then deny. This time I'm going to use host 192.168.1.230. Okay, so the first line allows 2.10, the second line denies 2.30. If we run show access list on this router, you can see what you have done. Okay, so access list, the first line is permit 192.168.1.2.10, and the second line is, you can see the sequence numbers here. We'll be talking about the sequence numbers in the upcoming video. And then deny 192.168.2.30. I didn't mention anything about 192.168.1.231. So this question may come to your mind. Okay, what would happen if we leave this ACL when we apply that, obviously, and we do not mention anything about 1.231 or any other IP addresses? The rule of thumb for ACLs is, as I mentioned before, each rule will be tested one by one from the beginning. And then if we reach to the end of the ACL and there is no any matching ACE for that specific traffic, there is an implicit deny at the end of each access list. So if the traffic doesn't match with any rule, then that traffic will be denied or dropped. So I want to show you how this works, and leave this ACL like this and doesn't mention anything about 2.31, and then we'll test this feature. Okay, so if I reset my terminal, I'll be applying this access list on gigabit 00 on incoming traffic, because these traffic from these PCs will coming inwards destined to router 2, and direction is inside or incoming. What I'm going to do is I go to interface gigabit 0/0, and then I would say IP access group, and then your access list number. In definition we say access list, in the application we say IP access group on the interface, and then your access list number, and then which direction you want to apply this access list. Okay, so now I am expecting PC1 and PC2 couldn't do what they were able to. So if I go back to PC1 and replicate the command, you can see that this time communication administratively prohibited. So this means that there was something wrong and this PC cannot communicate to that router anymore. Same should happen to PC2, because that implicit deny at the end should not allow this traffic going through. And as you can see, communication administratively prohibited. But if I go to my PC and try to SSH to that device, 192.168.2.2, you can see that I'm still able to access that router, and can SSH to that traffic. This is how you can filter your traffic using a standard IPv4 access list. And it can be applied to any traffic. So these two PCs wouldn't be able to access anything because we said nothing can go through. So they can't access anything further router 1, which might not be the case, and you may need granular filtering, which will be applicable via extended access list, which we'll be discussing in the next video. But for now, and for management protocols like SSH, we have another option as well, and applying the access list on the line VTY. So instead of preventing the traffic using a standard access list or even extended access list, we can apply the access list on the line VTY specifically for Telnet and SSH. This is how we do it, okay? So what I'm gonna do is I will be removing this access list, okay? So I would say no IP access group 1 in. This is gonna end up with having that definition, but that access list is not applying anymore. So now I'm expecting the communication again. And as you can see, I can connect to that device and there is some conversation between this PC and router 2. Now what I'm going to do is I'm going to router 2 and define my access list. So I'll say access list 1 and then permit 192.168.1.210.0.0.0.0 or access list 1 deny 192.168.1.230 and deny host. Same access list we defined in router 1, and then instead of interfaces like gigabit ethernet 0001 etc., I'm going to apply this access list on the line configuration. So I go to line VTY 0 to 15, and then this time we use access class. So on interfaces we say IP access group, and here we say access class, and then access class, which is access class number, which is your ACL number, and then in or out, which in this case is in. So if we say show run section line, you can see that on line VTY 0 to 4 and also 5 to 15, access class 1 is being applied. So again, if I go back to any of these two PCs, PC1 or PC2, and run the command again, you can see that you receive RST returned, which means that the reset flag is being set and returned to you, which means that you cannot access that device anymore. So this is another way that you can restrict the access to your devices. And for example, if you have a specific management boxes, etc. in your network, you can restrict Telnet or SSH to your devices only through those specific addresses or specific computers you design to as your management boxes, etc. Alright guys, this was our today's video. In today's video, we covered two exam topics, 5.6 as the previous video, configure and verify access control lists, and also 5.3, configure and verify device access control using local passwords. In the upcoming video, we'll be configuring extended IPv4 access lists. I wish you enjoyed today's video and see you in the next ones.